This is the final project for Engineering 433, completed by Brady Rudsel, Josiah Buxton, and Andrew Khela. The guidelines of the project specified that you're supposed to make a circuit that completed some type of function automatically. Since it was up to us, we decided to do 2x2 matrix multiplication. In the top left of the circuit is the opcode. The opcode is stored in ROM and is 13 bits long. The opcode is controlled by a clock, which can either be manually clicked through or automatically set to cycle through at a certain speed. On the left here we have the first matrice, and on the right we have the second. Going down we have the entries 1 by 1, 1 by 2, 2 by 1, and 2 by 2 for each. Down here we have the registers that store the data. When we did the math, the most compact way we could do it when we didn't need the values anymore was using 8 registers in order to get these. Down here is the resultant matrix stored in hexadecimal displays. In order to multiply two matrices together, you have to first multiply two sets of values and then add them together. That is going to be your first resultant value in your resultant matrix. The way we did it was register 1 and register 2 are going to be multiplied together and then stored in register 3. Register 1 and 2 are going to then be cleared and then loaded with the second set of values added together or multiplied together and then put in register 4. Register 3 and 4 are then going to be added together to be put in the resultant matrix. It's going to repeat this for the registers 5, 6, 7, and 8, and then it's going to be set to display down in hexadecimal in the resultant matrix. If we preload the matrices with values, we're going to go ahead and put 1, 2, 3, 4, 5, 6, 7, and 8 into the matrices. And then we're going to cycle through the clocks manually to show the proof of concept. As you see, since it's already on the first instruction, the first register is already in there. It's value 1 because it's entry 1 times 1. So if we cycle through the clock, it's going to put in 5, which is the next thing to be multiplied in. Then if we cycle through it again, they'll be multiplied together and put in register 3. If we continue this, register 1 will be cleared and the next value will be put into it. Then register 2. And then after we do this, the register 4, those two will be multiplied together. So it'll be 14, which is E. And then it's going to add register 3 and register 4 together and put it in register 5. If we continue this, it will keep going through and do that process 3 times again and fill up register 5, 6, 7, and 8, and then display them down here. As you can see, since we already did the first register and the resultant is 13, that's what the register 5 or hexadecimal display of that is displaying. So with the preloaded values that we already did, I can set the clock to just run automatically and cycle through at a given speed. So if I go down here and we look at the registers and the resultant matrix, I can click Control K and it will start to put the registers in, multiply them, reset the first 2, then multiply those, add into the first resultant matrix, display it, and then start over again. So multiply again, and then add into the second resultant matrix. Put in the next 2 values, multiply, next 2 values, multiply, and then add. And it's going to do this one more time. and should add again. There we go. That's the resultant of all of the matrix multiplication.